Hi, in this poster we talk about experience of using formal verification for a complex memory subsystem design. So here is the introduction. As we all know, memory subsystem is a very essential part of any SOCs. And traditional verification does not guarantee of catching design corner scenarios. Uses of formal verification for a complex subsystem is not an easy task because of its status space. Solving the problem of subsystem in a structured way, filling the gap of dynamic simulation using formal simulation. Uses of advanced formal verification approach to verify memory subsystem. Faster approach for a design verification bring up. Now let's talk about objective. To perform a formal verification of memory subsystem. So this is the memory block diagram of memory subsystem. It has got a 3 channel. Each channel consists of 5 IPs. The role of this memory subsystem is to ensure the data transfer takes place from the processor to different level of SRAM and vice versa from SRAM to processor. Now let's talk about verification flow. So initially we identified a formal vendor app. Once we identified the formal vendor F, then among those we used property and register verification check of individual IPs. Once we have checked for this two, we tried getting full proof of all these properties. So there were many properties which we didn't have a full proof. For that we applied a split based approach. After that there were some property which were unsolved. For that we applied formal engines, different formal engines for those unsolved properties. Once we have done for all these, for all the IPs, then we went for connectivity check between the IPs. Once we have all those things up, then we automated the regression flow and we ensured 100% coverage is achieved. Now let's talk about what are the methods that we used it for the verification. So here are the following methods that we used it. We used property check, connectivity check, register check, sequence equivalence check, ABBIP based verification, split based approach to solve the formal properties. So now let's talk about split based approach. So here is a split based approach. So a function is dependent on XYZ variable, and splitting is done in such a way that x is kept random where y and z are constant and vice versa. By doing this approach, problem complexity is minimized. Now let's talk about result. So of this split, using this split based approach, so RO and WO and RW, it indicates read only, write only, and read write one. Right? So these were the number of properties that were unsolved before the split, and after the split these are the numbers, and this is the percentage of using the split approach, and really by using that we had a significant results. Now let's talk about bugs found. So one performance issue which we found it, which would not have found through functional integration verification. We got 4 connectivity issues early in the project. 2 crucial IP design issues were found. Later, same thing were found in functional verification when the scenarios were developed to test the features. Registered verification, 1 issue was found. Conclusion: though formal was applied late in the project, but we got significant result. 9 issues were found in the architecture, performance, register, and IP design. Automation helped us to reduce the verification time. Faster verification for the design bring up. We got 6x ROI with respect to functional verification, and these are the reference. Thank you.